Welcome back to the channel. This is the Earth Science Classroom. This video is on geology and the principles of geology, and looking at one law in particular, which is the law of original horizontality. So this is looking at how the sediments are deposited and how this affects the fundamentals of geology and how we understand and analyze sedimentary rock layers and rock strata. This is the Earth Science Classroom. Before we discuss this geologic principle of original horizontality, we're looking at gravity. Now, gravity is a fundamental physical law which governs the processes and mechanisms of a lot of things on Earth, especially within Earth science and how things operate and function. So gravity has been amended over recent decades to fully explain what it is. And first, it is a attraction. It's a push or pull towards the central mass. The larger mass is distorting space and causing the smaller object, the less or decreased mass object, to move towards or around the larger mass object in space. So in this case, planet Earth is the largest mass, and we on the surface are under the influence of gravity and being pulled or pushed towards the center of the Earth, where the Earth's mass is centered. Now, this occurs at a rate or acceleration speed of 9.8 meters per second squared, and this is going to govern how any object, or let's say sediment or piece of rocky material, is deposited on the Earth's surface anywhere, because gravity will be the influencing force on that deposited material. So the strength of gravity can fluctuate across the Earth's surface based on various anomalies and rock geology. However, the general direction of gravity is uniform. It is going to be down towards the center of the Earth, wherever you are, and therefore the material that's going to fall on Earth or be laid down on Earth or be deposited on the Earth's surface will be under the influence of gravity and fall at a certain angle and at a certain speed or rate. So if you have a body of water, an ocean, and let's say you have sedimentary rock and you have a large accumulation of sediment that is being deposited onto the current Earth's surface, the small piece of sediment, the class or the rocky material that's being deposited, is going to fall under the influence of gravity and accumulate along the Earth's surface. Now, the Earth's surface could not always be flat or level or horizontal. However, the accumulating sediment will align itself to the current angle of the ocean floor or the Earth's surface based on the contour lines and also based on gravity. So the law of original horizontality proposed by Steno in 1669 talks about or discusses the fact that these rock layers, these rock stratas, are laid down and formed rock through lithification in a horizontal position or a horizontal formation. They're not formed at a diagonal against gravity. They're not formed always in a syncline or anti-syncline formation, but they are originally laid down in this flat horizontal or close to flat horizontal layer or strata or bedding according to gravity and according to the surface in which it's being deposited onto. So Steno stated that the law of original horizontality refers to the point of which the sediments are accumulated and lithified and form into rock. They form in a horizontal layer or bedding or strata across the Earth's surface, and over time you would have these rock layers being buried and being pushed down deeper as new, younger, horizontally laid down rocks are formed after. So you have the combination of both the law of original horizontality and the law of superposition working together. If there are no changes, no unconformities, no cross-cutting relationships, no changes to the area geologically in terms of folding or tectonic forces or volcanism, then you're going to have this lovely layered sedimentary rock in horizontal layers as laid down when they first formed. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on Earth science.